Um, at the end of the day, carbon can be a bit of a mystery to everyone. And it's a term that's thrown around in the media, and it can be a bit nebulous. So today's learning outcomes for the presentation, we're hoping to clarify what is carbon, how does it relate to greenhouse gases, how do greenhouse gases impact global warming and climate change, how do we measure greenhouse gases, what are the largest contributors to emissions for Ontario and Queens? So for the most part, I'm going to be focused on provincial and local level for the discussion, but happy to mix in or talk a little bit more at the end about more global-based issues. And I'm going to look at what the provincial and federal targets are. And lastly, we're going to talk a little bit about the Queen's emissions profile and how it aligns to those things. So hopefully that gives hi, Jim. I'm going to mute you there, if possible. And if there's any questions, feel free to ask during the presentation if they're sort of around clarification for what exactly we're looking at. But if possible, let's try and hold the questions till the end of the presentation. So to start off, I was going to go through some terminology. A lot of times carbon and greenhouse gases get interchanged and intermixed. For the most part, when people say carbon and carbon emissions, we're talking specifically around CO2, which falls into the category of greenhouse gases. So greenhouse gases are a global, sorry, I was just getting thrown off there by the people jumping in. Greenhouse gases are an overarching term that's used to describe several different types of carbon emissions. And so specifically, greenhouse gases are gases in the atmosphere, which are going to increase the ability to retain heat in the Earth's environment. So the main types of greenhouse gases that are tracked and logged and measured are carbon dioxide, methane, nitrous oxide, and fluorocarbons. So those four different items are sort of generated in a couple of different ways, and they have different global warming potentials. And so carbon dioxide, for the most part, comes from combustion. Methane comes from, for the most part, decomposition. Nitrous oxide is from primarily industrial procedures, and fluorocarbons are typically generated from refrigerants and refrigeration equipment and processes. So when we talk about carbon versus CO2, CO2 is specifically carbon dioxide, and CO2e is equivalent. So what happens is to create a standard unit for carbon emissions, we take the other types of emissions and we create an equivalent for what their value or impact is in the global warming process to the same as what carbon dioxide is. So anytime you see CO2e or greenhouse gas emissions, it's usually referring to CO2e, which is an addition of all the emissions converted to an equivalent that matches that of 1 unit of carbon dioxide. So hopefully that makes a little bit of sense. If you have a methane emission, say, for example, a landfill that's emitting methane, that methane has a higher global warming potential than carbon dioxide. So 1 unit of that gas, or it's usually measured by the weight of the gas, 1 ton of that gas, would actually have 25 times the impact of 1 ton of carbon dioxide. And so therefore you have to do the conversion to showcase them on a similar level and to create an equivalency. So hopefully that provides a little bit of context or explanation as to how those various gases sort of are made equivalent to one another. This is an overview based in the US on sort of the makeup of what we typically see for carbon dioxide, greenhouse gas emissions, and what the percentages are sort of in general. So you can see the majority of carbon emissions or greenhouse gas emissions are carbon dioxide, and then followed by methane, nitrous oxide, and fluorinated gases, so refrigeration processes. I'm going to just cycle back to the Ontario context here in our next slide to kind of link this back a little bit. So when we look here at, this is a breakdown in Ontario of the emissions that are typically produced. I think this was the 2016 or 2017 emissions breakdown. So you can see 38% of the emissions in Ontario were actually generated through transportation. The next big percentage was buildings, and the next was industry. So we think about, I'm going to go back to this slide here. If we think about carbon dioxide, which is typically generated through combustion, we can see what's driving that combustion. So we have vehicles burning gas, we have houses burning fuel, typically natural gas or heating oil. And then we have industry and industry processes, which also need heat and power and different types of gases that they would be burning. And then we have the others. And so when we look back at that mix of where the emission sources are from, we can kind of link that back to where the emissions are generated from. I think the one thing that I wanted to also highlight with this is that sometimes carbon and greenhouse gas emissions are a little bit delinked, or it's a bit of a nice way of not saying pollution. And at the end of the day, greenhouse gases are a measurement of pollution. And so I just wanted to make sure that I highlighted that and get everybody thinking about that. In Ontario, just to link that back to the provincial context, one of the things that happened was we phased out coal-fired generation in the early 2000s. Well, it's sort of around 2013, 2014. And one of the things that happened from that is that we saw a reduction in smog days, we saw a reduction in pollution, and at the end of the day, those greenhouse gases have improved the air quality that we see. So what happens though when greenhouse gases are emitted? And so, there's always sort of a question about what's the connection between greenhouse gases and global warming or climate change. And what I wanted to get across with this slide was that basically what's happening is the Earth is getting warmer. And the reason that happens is that as those greenhouse gases are emitted, they're staying in the atmosphere and they're reducing the ability for the Earth to release heat. So prior to the emissions increasing and greenhouse gas production increasing over the last 150 years, there was more essentially heat escaping into space. And there's less of that now because greenhouse gases act, and that's why the term greenhouse is used, is that it traps in the heat. And so the more CO2, methane, nitrous dioxide, and fluorocarbons that are emitted, the thicker and harder it is for that heat to be released from the atmosphere. So that's the link between the emissions that are released and how that impacts the temperatures of the Earth, essentially. So if we look back at sort of a pretty small time scale, we can see how that impact has happened in the Canadian context. So this is a really interesting graph that was produced from data from the Environment and Climate Change Canada, which is the federal government. And CBC News did this article and produced these bar charts. And what I really like about them, and I think is really interesting, is that you can really visually see the average annual temperature change in two major cities. They did it for more. I just presented these two. So you can actually see the impact in terms of average temperature. So it is really difficult for a person to notice the changes year over year. And what I found interesting too is if you look at the temperature rise or the average temperature from say the mid 2000s in both Toronto and Calgary, you'll notice some white bars intermixed with some of the pink and reds, which shows that, over a given time period, yeah, we did have some times where we had a cooler winter or a winter that was closer to normal or average. interspersed with some hotter ones. But in general, you can definitely see that trend of the average annual temperature increasing. So that's the shift from the blue to red, which I found to be visually quite telling. So hopefully that sort of also connects with you. The next slide here that I wanted to show was how do these emissions and temperature rises impact us? And so we're going to continue to see things like additional smog and air quality issues, sea level rise, sea temperature rise, and acidification of the oceans, which I'll talk a little bit more, is directly related to acidification and wildfires and flooding events. And we're also going to have to adapt because as temperatures increase, as climate becomes more variable, our infrastructure and our systems are going to have to be built more robust and be modified and changed to deal with broader ranges in temperature and weather scenarios. So there's a significant cost here to all of this, and I'm probably speaking to the converted, but hopefully this next slide also sort of drives home the fact that things have definitely changed. So one of the ways that greenhouse gases are measured are in the parts per million of CO2. And so CO2, as I mentioned before, is one of those, it makes up over 80% of the emissions typically. And so it's a good indicator. So this is a 2,000 year scale looking back at what's the impact and what's been the trend on global atmospheric CO2. And so you can see that really since the Industrial Revolution, we've seen a huge uptake in the carbon content in the world's atmosphere. And that's really what's driving climate change. So the next thing I wanted to do was link this back to the carbon cycle. And so if we think about the carbon cycle, and it's similar to the water cycle in that we have emissions, and in general, the emissions that are being added now into the system are those created by human impact. So those four gases that I talked about and the typical generation of them, which was the provincial breakdown, transportation, buildings, infrastructure, industry. And what you can see is those are the additive impacts. What's really neat is what absorbs carbon, and it's vegetation primarily, and it's also the oceans. The oceans and plankton specifically absorb and are major absorbers of carbon emissions. So if we link that back to what I was talking about before, which was sea level rise and acidification and wildfires, we're actually impacting some of the key systems that are absorbers of carbon. And so when we look forward at policy and regulation that should be used and should be considered, land preservation and naturalization and maintaining management of forests and forestry is absolutely critical, because there are main sinks and there are main ways of sequestering and reducing and pulling in and absorbing carbon emissions. So planting a tree is actually a huge impact. It's a great thing to do. And wildscaping your lawns, cutting your lawns less, letting them be carbon sinks are really some great things that can be done. The other one is that it tells us that we have to change the way that we're doing things here, and we need to reduce because it's one of the huge additive components of this. So we need to reduce and change the way in which we operate so that we produce less. So it's all about the reduce component here. This next slide I wanted to show, it's similar to the one that I showed before on the 2000 scale, but it's over 800,000 years. Because sometimes people say, oh, well, this is just one of the natural cycles of carbon emissions and greenhouse gas fluctuations and Earth temperatures up and down. And it's not, I think is the simple way to put it. We can look back over 800,000 years through work upon scientists that have been measuring CO2 levels in Arctic ice and ice cores. And we can see that, yes, there have been ups and downs in carbon emissions over the history of the Earth, but nothing like what we've seen in the last 150 years. And if you think about all the oil extraction and emissions associated with that, it's not surprising, I would say. So to come back to this again, if we want to change what's happening, we want to do better, we want to affect that carbon cycle, and want to bring down the parts per million of CO2, then we need to focus on the areas that have the largest impact. And so what's nice about, and what's important about carbon and greenhouse gases is to measure and to identify where we can affect change and where we can improve emissions and reduce those emissions so that we create a lower impact. And so transportation, buildings, at least at the university level, are things that we can impact. And then industry and other are ones that we can impact, I guess, in our personal lives. And so in our next presentation, the part 2 of this, I'm going to focus a lot more on the what we can do. But for this session, I was hoping to stay focused on how do we measure and what are our numbers at right now. So these are big numbers, and they still just tell us the breakdown. So then the next question is how do you manage what you're measuring? And we do that by looking at 3 different types of emissions within greenhouse gases. So we break emissions into what's called Scope 1, Scope 2, and Scope 3. So under typical greenhouse gas inventory protocols, and there are some formalized protocols through different standards organizations that have sort of identified the different way in which we can account. So they're basically accounting protocols for emissions. And so specifically, Scope 1 is typically emissions that are generated on site at your facility or by you at your home. So I'm going to talk a little bit more on the next slide about that one. Scope 2 are indirect emissions, and Scope 3 are also indirect emissions, but they're associated with travel, waste, water use, and procurement. Scope 2 are specifically electricity or other purchased utilities. So the easiest way to explain Scope 1 and Scope 2 is that they are items that the end user can control the use of. So the example being in your house, if you have natural gas furnace, let's say, that's a Scope 1 emission because you actually have a exhaust and the emissions are being generated at your house. And you have control over what you set your thermostat to. If you also have a hot water heating tank or you have electric stove, microwave, lights, etc., that's also controlled specifically by you. However, the emissions associated with generating that electricity are happening elsewhere. So for the power plant that's producing that electricity, that would be a Scope 1 emission. But for you as an individual, that would be a Scope 2 emission because you can control it. You can turn the lights off and on. You could put in LED lights if you want. You could buy a heat pump type hot water heater, which is slightly more efficient, and etc. And the other scope is Scope 3, which is typically comes down to your impact as a consumer and or your impact as somebody who is taking transit perhaps, or the way in which you deal with your waste. And so for the university, it has to do a lot with our procurement. It has to do with our employee travel and our waste and organics diversion. So those are our Scope 3 examples. And Scope 1 for us is our emissions associated with heating our buildings, our fleets, our vehicle fleets, our grounds equipment, some of our lab equipment, and scope 2 is in all of our electricity use. So hopefully that sort of makes sense and allows people to understand how we break down those different scopes. So in general, just to sort of come back to that, scope 1 and 2 are typically easier to measure, and the end user has more control over their use. Scope 3 emissions are a little bit more difficult to quantify, but if they are being produced in a jurisdiction that has reporting and accounting regulations, then those companies and institutions or providers are also required to report their emissions if they're over a certain size, or if they're, say, a service provider over a certain size, like a Enbridge or Union Gas, they'd have to report the end use consumption for any sort of smaller organizations or companies. But as a sort of a recommendation in general, for scope 3, purchasing products with a longer life cycle and ones that are reusable will always have a lower carbon impact. Life cycle analysis is something that we apply to purchase goods and scope 3 materials or services, because it allows us to evaluate whether or not we should be choosing one product over another based on the energy and emissions that are associated with manufacturing it. So do I want a product that is made of steel or a product that was made of wood? One of them actually might have a much lower carbon emission profile than the other. One might last a little longer, one might last a little shorter. So if I have to rebuy that on a higher frequency, conducting a life cycle analysis or a life cycle carbon analysis allows us to investigate that in a further fashion. And there's some researchers here at Queen's that are doing some really neat work on that. So now that I've talked a little bit about the emissions types, I thought I would talk a little bit more now about the federal and provincial reduction targets, which have come about from different sort of, I guess you'd say, world conferences and the climate conferences. And the latest one, or the one that people are most familiar with, is the Paris Agreement, which committed Canada to reducing its greenhouse gas emissions by 30% below their 2005 levels. So you have to pick a target and then start striving for it. Ontario currently has the same target as the federal. However, with the change in provincial government in 2018, a lot of the regulations and the climate cap and trade program that did exist in the province was canceled. And so the Auditor General has found that, even though we do have targets in Ontario, they're at risk. And I've included the link to the auditor's report, so you can have a look at that if anyone's interested in digging into that a little bit more. So where does that leave Queen's? Well, Queen's took the step back in 2010. We signed on to a Canadian-wide, statement of action around making plans and developing a climate action plan. And it took a while, but in 2016 we published our final plan, and this was approved by the board, which was great. And so it lays out targets for the university, which are substantial and significant, which lay out a target of a 35% reduction by 2020, 70% reduction by 2030, and to be net zero by the time we hit 2040. And that's all based on a 2008 baseline. So the federal government has a 2005 baseline with a 30% reduction by 2030. We have a little bit of a later baseline, but it's still a good baseline to go off of, and it's 70% by 2030. So we're further ahead than the federal government. And I think the other thing to note about the emissions is that this one's what we call an absolute target. So even if the university grows, we still have the same responsibility to reduce our emissions by that percentage, by that 70%. So our baseline doesn't change, even if the university continues to add and build new buildings, which we have since 2008. Each year, I talked a little bit about the different scopes of emissions that we calculate, and each year, our office, we pull together a carbon footprint for the university, and we calculate both the Scope 1 and Scope 2 emissions. We haven't been able to quantify our Scope 3 emissions. However, institutions that have found that typically their Scope 3 emissions are almost as large as their 1 and 2 emissions combined. So if anyone wants to have a look at the greenhouse gas inventory reports, they're on our sustainability website. And so I encourage people to download that and have a look at it if you're interested to see the details a little bit more. But I'm going to run through a couple of the data points that I pulled out from previous years. So this is looking at the targets we laid out in 2016. And so in the first column here, I've got the target, and then I've prorated the baseline for the specific year based on the overarching target of 35% for 2020. So back in 2008, we were emitting close to 57,000 tons of greenhouse gas emissions, and primarily that was from our heating plant, which heats all of the campus as well as the local hospital. And by 2020, you can see we actually reduced quite a bit through a series of initiatives. And in 2020, I've got an asterisk just beside this because we haven't verified the data, but I went back and pulled all the information, and based on my expectations, we'll be just over our target at 36%. So what I find really interesting about this, and I have a few more slides to outline this, is that even though these emissions have gone down, our campus has actually increased in size, and our campus population has grown quite significantly as well. And there's two main drivers to this. We have instituted quite a few projects to reduce our emissions, but the other really big factor around this was that the electricity grid in Ontario became a lot cleaner with the phase out of coal. So that phase out of coal was a big impact to our emissions profile, because we've actually been able to shift some of our heating systems over and heating requirements to electric. And the biggest example of that is the St. Mary's of the Lake redevelopment, which will be a geothermally heated, our first geothermal system for heating and cooling. So with that, oh, sorry, I think that's the wrong slide. I'm going to skip by this questions one because it's oh, where did my other slides go? Oh, I'm missing a few slides in here. I wanted to show you a couple other slides. I'm not sure what happened there. Sorry, just bear with me for a second. I'm happy to take any questions while I'm just pulling up the slides that I think I deleted somehow. Are there any questions?
I'll have one. Susanna Cliff-Jungling. I'm just wondering, you said that Scope 3 we don't quite are able to track at this point, and yet potentially, as you pointed out, it could be a fairly large number. So what are the plans, or what are you thinking? How are you going to go about tracking, measuring Scope 3?
Yeah, that's a great question. So the difficulty with Scope 3 is that it requires input and information from a lot of our suppliers and anybody that we're buying things from. So there's the data collection component of it. And so I think the easiest way to start to track that is actually by building into the procurement system a requirement for suppliers to also indicate what the carbon intensity of their products are. And once we know that, we can actually score and provide incentives and or base requirements for suppliers and manufacturers to meet to then make the grade to be purchased by the university. So it's all about building into the procurement system, and there is something called extended producer responsibility and circular procurement, and there's a couple of procurement concepts that are being developed quite significantly in the province, and they're all around we're basically rewarding manufacturers that are making a lot of headway in creating reusable products and products with low carbon intensity.
And we had another question, Nathan, if you wanted to answer it while you're searching. It was, how do you plan to go to net zero emissions? Are you considering renewable energy?
Oh, yeah, definitely. So our strategy for getting to net zero is going to be it'll be a multi-pronged approach for sure. We previously looked at solar, and what's happened in the province a little bit unexpectedly, but perhaps not, is that because of the cleaning of the grid and the electricity grid being as low carbon intensity as it is, our strategy for getting to net zero is going to revolve a lot around using more electricity and relying on the electricity grid to be clean in the same way as it is now. So operational efficiencies, reducing our need for heating and cooling as much as possible by, ensuring that our new builds and existing buildings are as energy efficient as possible. And then the second is converting and utilizing a clean grid. Renewables will fit into that, but probably it's harder to justify. So in the example of solar panels at the university, you can invest and purchase solar panels and install them on the university, but the benefit of that is actually from a carbon standpoint is quite low because the grid is already very, very clean. Are there any other questions?
I don't see any popping up in the chat right now. Actually, we have someone raise their hand. Did you want to go ahead?
Hi, it's Charlene. Can you hear me?
Yes.
Oh, I was wondering, you've focused on greenhouse gas emissions and atmospheric pollution. I was wondering if you talk at all about thermal pollution and the waste heat into the lakes from our nuclear power plants. Because I know you said it's a clean grid, but it's not a clean grid actually when you look at the radionuclides that are emitted and the fact that for every kilowatt of energy you get 2 kilowatts of waste heat into the lake, and all of the emissions from the extraction of uranium in northern Canada.
Yeah, no, I won't say that I'm there's nothing that I can disagree with you on that. It's the difficulty for us as the university is that we have to try and find an overarching strategy that's going to reduce our emissions, and with the hope that the province continues to make the grid cleaner and reducing our reliance on the grid and grid-fed electricity. So we manage our Scope 1 emissions as much as we can. We build as efficient buildings as possible, and I can't disagree with you. It would be great if we strengthened our interconnections with Quebec and could bring in more hydro and wind, and if the province would stand behind and develop more wind and wind power, and then the next step would probably be looking at storage. So at the provincial level, you're right. There's an opportunity to do better. Our nuclear power plants are extremely expensive to operate and maintain and manage. there is a big thirst for electricity in the province, and managing that is not straightforward. So, but yeah, it's a complicated issue. Is a simple way to put it. I see a couple more. Amy, did you want to read out if any more items came through in the chat?
Yeah, they're mostly just questions about the presentation afterwards, but I see there's one hand up, or maybe not.
Yes, I do have a follow-up question. Sorry, Suzanne, again, just the comments you made, but it wouldn't, well, maybe you get to this in the next part, but this, yes, we have a demand for electricity. Maybe we need to curb our demand. I mean, if we want to go to net zero, do we actually think we can continue to live the way we do and get to net zero?
Yeah, it's a great that's a great point. So reduce is going to be definitely one of the big components to the strategy, and you're right. Right now we're pretty energy dominant society, and so looking at how much we travel, and that's the other piece to it, right? So if you look at the emissions breakdown that I showed before, over 50% of our emissions are from transportation and buildings. So that's where, you know, if I was writing the regulation, that's where I would be looking to target. And how and why we travel so much and drive so much and use so much transportation is a great question to ask. And whether, you know, I'm a big fan of public transit. I think it's not as well developed here in Canada as it could be, as it is elsewhere. The interconnections between cities could probably be served, and we could reduce a lot of the cars and vehicles that are on roads. So there is some questions that have to be raised and discussed around how we move between cities and how we work and play, I guess you would say. But those are really conversations that I guess can be had or encouraged through the university, but it's for our office and what we do on the facilities side, it's harder for us to get into that topic. So I did find the slides that I had in my slide, and I must have deleted them out, so I do apologize for that. I wanted to show a couple of slides on how we've been doing at the university on our carbon emissions over time, and sort of break out a few other metrics. So one of them is for the Queen's context specifically. On the right here, we've got our emissions in Scope 1 and Scope 2 added together in metric tons of CO2 equivalent. And on the left is the intensity over the square footage that we have on campus. So what's great and what I'm pretty proud of is that over the years we've actually been able to drive down both our emissions and our intensity levels at the university. So that has to do with good building practices for new construction and efficient use and management in our existing buildings right now. So I always find that one to be a bit of an interesting slide. This next slide is, I like to show this one because it shows essentially the ratio of how the yellow line going upwards is showing the increase in our square footage on campus. And so, or sorry, square meters. So we've actually added almost over 100,000 square meters of space on campus since 2008. We've put up almost, I think we've put up 8 buildings over that time, and they're quite large too. And again, you've seen that the emissions have actually decreased over that period of time as well. We instituted a big project in 2018. It finished, the winter of 2019 it finished, and it was severance of the steam line that used to run out to West Campus. And so implementing that project reduced and putting an independent heating system out at West Campus made a really big impact on our emissions profile.